Hello, in this video, I'm going to teach you the calculation of specific heat capacity. To start with, the specific heat capacity is the amount of heat required to raise the temperature of 1 kilogram of a substance by 1 Kelvin. The SI unit is joules per kilogram per Kelvin, and this is the symbol, as you can see. Okay, remember that the quantity of heat is given as this. Okay. Yes, this is the mass of the substance. This is specific heat capacity, final temperature, and initial temperature. Okay, so when we make C subject of the equation, we are going to have our specific heat capacity formula as this. So Q over M brackets final temperature minus the initial temperature. Okay. All right, so we are going to have this equation. So this is for specific heat capacity, this equation, okay? So where Q is quantity of heat, and then C is the specific heat capacity, M is the mass of the substance, okay? And this is change in temperature, the final temperature and then the initial temperature. Let's take an example to learn how to apply this equation. In this example, we are asked to calculate the temperature found when 15 kilogram of water at 90 degrees Celsius is mixed with 35 kilogram of water at 20 degrees Celsius. So we have two different water with different temperature here mixed together, and then we have been tasked to calculate the final temperature of the mixture. So to begin with, we need to write out all the parameters. So in this problem, we have hot water and cold water. So let's say we have hot water. Okay. So let's write out the parameter for that of the hot water. So 15 kilogram is the mass. So we have 15, which is the mass. And then the initial temperature is this. So initial temperature is this, which is 90 degrees Celsius. And what again? Specific heat capacity is of water is always given as this, 4.2, okay? And then let's consider that of the cold water or warm water, if you want to say warm, but I think it's cold, whichever. So here we have the mass of this water to be 35 kilogram here. And then we have its initial temperature to be, what do we have? 20 degrees Celsius. And then the same thing, specific heat capacity is of water is also the same as 4.2, okay? We are looking for the final temperature of the mixture, okay? So we need to find the final temperature of the mixture. So to do that, let's apply our equation. Remember that heat loss rather is equal to heat gain, okay? Heat gain. All right, so we have our equation as this minus this, right? Equal to heat loss. Heat gain. So we need to put negative sign here. I'm going to tell you the reason. We have MC brackets this again, change in temperature. Okay. So we are putting negative sign here to get our value correct. Just remember in your chemistry, when a certain atom is gaining an extra electron, it becomes negatively charged, right? So we are using the same process here. All right, so let's just substitute the data we have into this simple equation, and then we see what we can arrive at. Okay, so we have mass, which is 15 times 4.2, the initial, the specific heat capacity of water, then bracket this. Initial temperature is 90, so we are writing it as this, equal to, let's not forget our negative sign. So second is 35 times 4.2, okay? Then we have this, let's put them in brackets, minus initial temperature, which is 20, okay? All right, 15 times 4.2. So when we multiply 15 by 4.2, we should have 63 here, bracket this, minus 90, okay, equal to minus, okay, 35 times 4.2. 35 times 4.2, we are having 147, rather 147, then bracket this, minus this. Okay, so let's open the bracket now. 63 times this, we are going to have something like this, minus 63 times 90. So let's quickly punch the calculator. What are we having? So we are having 5,670 equal to minus 147 times this. We are having this, something like this. Then this becomes positive this times this, okay? So let's multiply. What do we have? So we are also having 2,940, 2,940. Okay, so let's bring this here, and then this also comes here, okay? So we are having 63 theta plus this 147 theta 2 equal to this plus, what do we have? 5,670, right? So 63 theta plus 147, we should have 210. Yep, 210, okay, equal to this plus this. What are we having? We should be having 0 plus 0. We should be having 8,000. Yes, 610. Is this correct? Yes, 8,610. Now we are going to say our final temperature will now be 8,610 divided by 210. And when we do that, this dividing this, so we should have 41. Yes, 41 degrees Celsius precisely. So this is the final temperature of the mixture. Can you see it here? So this is how to apply this equation and how to find the specific heat capacity of a substance, or to calculate the final temperature of the given mixture, yes, of a given substance. So thank you for taking your time to watch, and if you are not following this page, endeavor to do so that you can receive updates of new lessons. In my next video, I'm going to show you how to do that of the electrical method. Goodbye for now.